Hey guys, welcome back to another interesting video of microwave amplifier design. As usual, I have a few recommendations for you and one prerequisite going for further videos that you should have studied this Smith chart. I'll try to make you recall Smith chart, but it will be great if you recall on your own. Okay, so let's start. So today we're going to derive a circle equation for unilateral gain, and I'll come to later why I'm calling it circle. Okay, so let's see something before I go to derive the circle equation. Uh, designing a micro amplifier have few steps included. So your first step is to select a device. Selection of device depend on many things, like for your gain, how much gain do you need, because in the equation of your gain we have one part S21 and S21 come directly from the device. So selection of device could be because of gain or could be because of your frequency range. If you want to do it for millimeter wave in 5G spectrum, like millimeters 5G spectrum, then it must include that 30 gigahertz range. So there are many factors we can select our device. After selecting a perfect device, the next step is to see the stability criteria. Is your device stable at your operating frequency range? If it is not stable, then we need to stabilize our circuit for that frequency range. Till now we have not discussed anything about stability, and I am postponing it for in the further videos. So for now, just you need to remember that we need to check for stability. And in today's video also we are not discussing about stability, because we will take this condition. We have two type of design. One is unilateral, another is bilateral, and these two things got decided by the device. If our S12 is 0, then it is unilateral, otherwise it is bilateral. And for today's topic and for few more topics, our main concern of discussion would be unconditional stable circuit. So we can skip this step. After that, we need to fix our gain. It's always good, it is actually always not good to have the maximum gain, because there might be some constraint on gain. So we need to fix our gain, and in our specification it always they have mentioned your employer or the organization will give you the specification, like you need to design it for this much dB of the gain. So you need to fix the gain. And how we fix the gain? We fix the gain by deciding on our gamma S and gamma in. As we know that in the equation of gain we have this factor gamma S and gamma in, so we need to decide on gamma S and gamma in. Actually, for designing a microwave amplifier, our main task is to derive this or get the value of gamma S and gamma in. If we get the value of gamma S and gamma in, then after that our work is very simple. It is just to design the matching circuit. Like we need to design our matching circuits in such a way that it realizes a gamma S reflection in input side, and a circuit means a matching circuit in output side that it realize not actually gamma in, excuse me, gamma S and gamma L. Our output circuit should be in such a way that we realize a gamma L reflection coefficient here. Okay, so these are the steps, and why this, using these steps I can design for unilateral also and for bilateral also. If it is potentially unstable, then we need to do the stability criteria, like we need to stabilize our device, otherwise we can skip this part. So now main focus would be that we want to decide on gamma S and gamma L. So if there is some way that we can tell, like for example I want a 10 dB of gain, then from 10 dB how I'll go to gamma S or gamma L value, because our main concern is to define the value of gamma S and gamma L. After that I can design full circuit for my amplifier. So that means we need to have some mechanism by which we can go from the gain to gamma L or gamma S. And we know in our Smith chart, any point like this point, they tell us about the reflection coefficient. So if this Smith chart is in the input part of my circuit, then any point I'll call it as gamma S, and if it is in the output part, then I'll call it as gamma L. So if we have some mechanism, like if they have given me gain of 10 dB, and I can do some mathematical manipulation, and from 10 dB if I try to get a equation of circle in such a way that each point of my circle will give me some value of gamma S or gamma L. And if I design my circuit with those gamma S or gamma L, then if they can guarantee that I'll get a 10 dB of gain, then our work will be simple. Let me tell it again. Like if we have some mechanism by which from our specifications or specified gain I can draw one circle in my Smith chart, and if each point of my circle give some value of gamma S for input part and some value of gamma L for output part, and after designing with those gamma S and gamma L, if I get the same gain which I have got specified, then our work will be simple, because we have some way from which what we are able to do from gain to gamma S or gamma L. Because from gain we can't directly make our circuit, we need to have the value of gamma S and gamma L. And this technique which we will derive today, it is called unilateral constant gain circle. From the definition only, from the name only, you can understand that it is only valid for S12 equal to 0. If S12 is not equal to 0, then also we have some techniques, and we'll definitely look upon those techniques in our upcoming videos. But this is a topic for today, that we will take unilateral case and when it is unconditionally stable. Why I am not taking the case of potentially unstable circuit, because still now I haven't gone through the stability criteria, how to stabilize my circuit. That's why when I'll take up the stability topic, then I'll just extend this topic for unstable circuits also. And if you know for unconditional stable circuits, then for stable circuit it is very easy actually, just you need to do some manipulation little bit, but main topics or main steps are similar. So in this subject we will have many circle equations. Like today we are doing for constant gain, then we will also have some VSWR circle, we will also have for noise circle, we will also have for operating gain circle and available gain circle. These two are specifically used when S12 is not equal to 0. But today what we will do for constant gain circle, and it is got derived for GT, our transducer gain. Don't be confused, we have three definition of gain, and I will make you, like I will show you the way from which if you design it for transducer gain, you can go from transducer gain to your GA, and from transducer gain to your operating gain. You need to design for one, and you can just convert your gain to other definition of the gain. But don't be confused now, because for today only concentrate on GT. I'll take up other gain and when specifically those gain are used in my subsequent lectures. So let's quickly revise circle equation. Those you know, you just increase the playback speed to revise it again. Okay, don't skip, because I might take up some point which you don't know, so don't skip. So if you have a circle here in your xy coordinate, and if we have a center is defined by x naught, y naught, then defining a circle equation means we want to know the value of x and y in any point of our circle. Like if I take any point here, then I should be knowing the value of my x and y from my equation. Like every point got defined because of our circle equation. So this is the main purpose of defining any equation, and circle equation is given by, like for example, if this point is called x1 y1, then circle equation is defined by x1 minus x naught whole square plus y1 minus y naught whole square equal to r square. And how it is coming? It is coming because of a simple mechanism. From here to here, this is your r radius, and if you want to know the distance of your length of your radius, then what is the equation? Equation would be this distance square plus this distance square and whole root over Pythagoras theorem. Okay, and this distance is nothing but your x1 minus x naught square plus this distance is your y1 minus y naught whole square and then a root over, and which should be equal to r. But if I square both the side, then this square root will vanish and we will get this equation. And this is, we all know from our class 10. But the new thing which I'll do here, it's for complex number. And why complex number? Because we are dealing with our gamma s, gamma in, and they are nothing but they all are complex. So if we are deriving any equations, like today we will derive equation for constant gain circle, then and constant gain circle will be in term of gamma s or gamma l, because we want to know the equation or circle equation where each point of my circle will give some value of gamma s or gamma l, and they are all complex. So we need to derive same circle equation in complex form. So in complex form, like if your z and z naught are two complex number, then this is your circle equation. From here to from here look little unfamiliar, so let's try to move from here to here. So z is my complex number, so I can write it as a plus jb, and z naught could be a naught plus jb naught. If I put them here, a plus jb minus a naught plus jb naught whole square, and if I expand it, then I will get nothing but this thing, plus b minus b naught whole square, and it should be r square. Now see, these two equations are same to same, and from that we can say that our z naught is the center of this equation of this circle. I'm just making you recall previous things, so I'm skipping one or two steps here, but I'm just giving you the reminder how this is also called circle equation. So now we are convinced that this is also a circle equation, right? And this could be also be written as z minus z naught, z minus z naught star. Am I correct? Because any complex number a and a star could be written as in this style. So I am doing nothing wrong here. And if I expand it further, then it will be z mod whole square minus then I can also write it again, z naught z star minus z naught star, right? Because outside of the mod, conjugate can come inside. This is one theorem. And if I extend it further, then I can write it as z star minus z naught star minus z naught z star, and minus plus z naught star, or z mod whole square plus this part z naught whole square minus z star minus z star z naught. And why I am doing these things, it will be got relevant little later now, but you need to remember this thing. And from where it is coming out? It is coming out from our circle equation. So that means, if anywhere I get something in this form, then quickly I can tell that it is the equation of circle with z naught as my center and z star as that point, and this is equal to our r square radius, because everywhere r square is coming. I just have omitted it. Okay, so r square. So we need to remember this equation. Okay, not remember for lifetime, for this video only, because in next step I'll do something and I'll bring that equation to this form, and I'll prove that yeah, this is the equation of circle. So just remember for few minutes, next few minutes. Our gain, amplifier gain, is defined as GS into Z naught into ZL. This is because of input part, this is because of output part, and this is because of our S21, which I can't change because I have already selected my device. And constant gain circle means I am defining it as constant. That means I have selected a gamma S which give me some constant value of GS, and I have selected one gamma L which give me a constant value of GL in the output part. And how I will select this thing? I will draw the constant gain circle. And constant gain circle means if they have given me I need a gain, so let me call gain as G equal to 10 dB. Then from this I want to develop some mechanism to draw one circle in my Smith chart. Okay, so for that I have a few procedure or few steps, so you need to see step by step. First step is to define your GS max or GL max. So for now let me do it for GS, and the thing I am doing for GS will be exactly repeated for GL. Only for GS I'll use S11, and for GL you will use S22. So what is my GS max? From last video we know it is 1 minus S11 square. This is the maximum GS I can achieve, and this is happening when I am taking gamma in equal to gamma S conjugate. And gamma in, because of it is unilateral, so gamma in is our S11, because see here you have gamma in equations, and if you put S12 equal to 0, then it is only S11, so that's why I am getting here S11. And if I put this thing, then from equation of GT, this is my GS part, this GS part will be maximum, and this maximum number is this thing I have did in my last video. So this is your GA max. So my specification need my G to be 10 dB, and my G has 3 part. One is from S21, and let's see, our S21 is already giving me 5 dB gain. So that means my GS part should give me 2.5 gain, or like this should give me 3 and this should give me 2. So for symmetry, let's take 2.5 and 2.5. So this is my GS, that is I need to achieve 2.5. And my, what would be the range of my GS? My range of my GS could be from 0 to equal to, it should be up to how much it can gain? It can go up to GS max, because this is the maximum gain I can get from input part. So in step 1, what we'll do, we'll define normalized gain, source part gain, GS gain, and it would be the given gain what I need to realize divided by GS max. GS, I know from here, it's 1 minus gamma S whole square by 1 minus gamma in gamma S mod whole square, and GM max 1 by 1 minus, so it will be 1 minus S11 whole square. So this is your step 1. Now we need to expand it in such a way that I get a equation of circle. And in equation of circle, what I need each value, each point should give me a value, because I will draw this circle in my Smith chart. So each point will give me one gamma, and that gamma will be gamma S or gamma L. Yeah, it will be gamma S, because we are doing it for the input part, for the gamma S part. So each point will give me some gamma S point, and gamma S is a complex number, you are convinced? So our circle equation should be looking like this: gamma S minus something equal to the radius of my circle, and here I will have the center for my circle. So from here I want to deduce to this equation, this type of equation. So that means if I do some mathematical manipulation and I convert this equation to something like this, then I have done my work. I have derived the equation of constant gain circle. So let's try to grow from here to here. So I can expand it as GS 1 minus gamma in gamma S whole square equal to 1 minus gamma S whole square and 1 minus S11, and this could be expanded to something like this form. Okay, so it will be equal to GS first part mod square, so it will be 1 only, minus second part as it is, and first part conjugation, so it will be 1, nothing to do, and then this part conjugate and into 1, and plus the second part mod. Correct? Equal to 1 minus gamma S whole square 1 minus S11 mod whole square. Now what we need some equation in gamma S minus something form. So that means gamma should be in left half of our equation. So let's try to bring all gamma S in one side. So it will be minus gamma S gamma in minus GS gamma in gamma S star plus GS gamma in gamma S whole mod square, and from this side I'll get minus S11 whole square. Sorry, I don't need to bring S11, I need to bring gamma S, because I am getting gamma S in one part of my equation. minus gamma s s11 whole square equal to 1 minus s11 whole square and minus gs, because this gs into 1 will go in this side. So let me take gamma s mod whole square as common, so I'll get gs gamma in whole square. This part is gone, this part is also gone, plus 1, and this part gone, minus gamma s whole gamma s already taken the common as 1 whole square, and we are left with gs gamma in gamma s minus gs gamma in gamma s star equal to 1 minus s11 whole square minus gs. Okay, now one thing you see, we have written gamma in here, some gamma in, but it is for unilateral case, so we can write gamma in equal to s11. Now if I divide my both sides with this term, then I'll get it as gamma s square minus gs s11 gamma s, and this part will come here, minus gs s11 star gamma s star, and the same part will come here, equal to 1 minus s11 whole square minus gs, and same part will come here. Now is the decisive movement. Now our z from this equation and this equation, our z is equal to gamma s, and z is defined, what is telling z telling me, it is each point of my circle, and we want each point of my circle should denote gamma s, so we are successful. Now what is our z naught, because z naught will give me the point of my center. So if gamma s is my z naught z, so see here my z part is getting conjugated, means this part, so my z naught is this thing and the below denominator term, so my c, okay, let me write z naught only, which is nothing but our center, equal to gs s11 star and the below part, which is 1 minus s11 square 1 minus gs. Now what is my r? This part is my r, okay, r square, but in my left half side I also need to have z naught square, but I am not getting z naught square. Here I have only 3 terms, so that means my z naught square has come here, minus z naught square, so that means my right hand part is equal to my r square minus z naught square. And just right now I have derived, I have got the value for z naught, so that means I can get the value for r easily. And if you do it, then your r will be root over 1 minus gs 1 minus s11 whole square by 1 minus s11, this is mod square, by 1 minus gs, and hence this is your point, this is your center. That means I can write gamma s, let me call z naught as my cs, so that means if I put it in the form of circle equation, that then it is gamma s minus cs, and here this is my radius. So I have started with my specified gain, and I followed few steps, and I got a equation of circle. Now I have the center equation for center, and center equation of my center need. It need S11 value. GS value is a normalized value which I derived from the specified gain. Everything I have actually. So that means, because S parameter will be given, the transistor S parameter will be given in my data sheet, so that means I can get the value for my CS center. I can also get the value for my radius. So that means in my Smith chart I can draw a circle, and each point of my circle will give me many unique value of gamma s, but all unique value of my gamma s will give me constant GS, constant gain. And we will prove this thing in our next video when I'll do the simulation using ADS and Serenade. So I'll do the same things. I won't be doing the derivation again. I'll take this equation directly and I'll make you understand, like prove this thing, that yeah, if we follow this procedure, then this circle or any value of my gamma s will give me the constant gain. So this is the summary what we have did today, and this thing we have did for input part, but same equation, everything as it is, will reflect in our output part. Only our S11 will be got replaced by S22. Now one fact, that our GS or GL equal to 0 dB circle will always pass through the center of Smith chart. GS or GL equal to 0 dB imply it is 1 in linear scale, and your GS or GL, let me write it as GI, is given by 1 minus gamma I whole square 1 minus SII, it will be 1 1 or 2 2 into gamma I whole square, and this thing will be become 1 only when our gamma I equal to 0. And gamma I equal to 0 means, if we remember our concept of Smith chart, any point of the Smith chart will give me the value of gamma s, and if this is this point, then this line will give me the magnitude of my gamma s, and this angle will give me the angle of gamma s. So if my circle, 0 dB circle, passes through the center, that means one point at least imply my gamma s or gamma L equal to 0, because magnitude is 0 and angle is 0, and that is what is required for GS or GL to be 0 dB. So that's why, like in any interview, if they ask like why 0 dB circle passes through the center of your Smith chart, then you can put this explanation to them. So that's all about today, and we are doing theory for last 3 or 4 videos. I know you might have got bored, but I promise in my next video I'll take ADS or Serenade. ADS, doing these things in ADS is very easy. We don't need to remember any formulae because they are already put through in ADS. But if we do in Serenade, then we need to calculate this manually, or I have something to automate this calculation. I will tell you when I do it for Serenade. So still then, wait for my next video, and if you have not subscribed, subscribe it now.